Hello there, Cardinals. It's me, Mr. Ernst, and in this video we are going to be talking about dilations. Notice this is the first one we're going to be talking about similarity with, and we're going to get more into the difference between congruence and similarity later, but for now we're going to learn how to dilate a shape. Now, what does it mean to dilate a shape? We've talked about sliding, we've talked about rotating, and we've talked about reflecting. Dilating a shape means that you're going to take the shape and you're simply going to make it bigger. You're going to make a much larger shape, which is important. Part of this, and part of the reason I wanted to talk about this, is that I want you to notice that all of these points are moving out in two different directions. They are growing vertically and they are growing horizontally, okay? And why that's important is that if you don't do that, you start to get shapes that look, if you, for example, only make it tall, you're going to get a you're going to get a shape that's really squished. Or if you only make it wide, then you're going to get a shape that's really squished this way, which we don't want. We want a nice, even, grabbing from the corner here, stretching it out to make a nice, even shape. It should look like the original, right? This looks like the original. This is a dilation. So let's take a look at what this looks like on an actual math problem. Bam. So here we go. Dilate the shape by a scale factor of 2. The way that we dilate a shape, we always have to know a scale factor because that tells us what we're actually doing to the shape. We have a scale factor of 2, so that means the size of this shape is going to double. If this was a 3, it would be tripling. If it was a 4, it would be quadrupling. So this is going to grow twice its size. Now this is done very, very similar to how you would do translations or rotations, in that you want to take this very much point by point. And for example, looking at the point itself. So starting at A, we'll start with A. A starts at the point 0, 3, and 3. So A is at this point here. When we have a scale factor of 2, that means we're going to be multiplying 2 by both of these to get our new position. So A prime is going to be at 2 multiplied by 0 gives me 0. 2 multiplied by 3 gives me 6. So if this is A, the double, the scale factor of 2, puts A prime at 0, 6. So staying at 0 and going all the way up to 6. So there's my new point up there. Actually, no, I'll do this one in red. Or let's do orange. So here is A prime. For the next one, we're going to have B and B prime. For the next one, we have B is at 0, 0. 0 multiplied by 2 is still 0, and 0 multiplied by 2 is still 0. So B prime isn't actually going anywhere. B prime and B are actually going to be staying at the exact same zip code. Finally, we have C. Looks like C is located at 2, 0. So C is at 2, 0. Again, we got to multiply both of these by the 2 up here. So 2 times 2 is going to give me 4. 2 times 0 gives me 0. And so I'm going to put my point in here at 4, 0. So right here. This would be C prime. Once again, I can connect all of my points now. And now you can see the triangle has now doubled in size. It has grown twice its size. Now we have this giant orange triangle dwarfing the small blue one. Again, I want to emphasize that when you dilate, this spread in this direction vertically, and it spread in this direction horizontally. Cool? It is moving in two different directions at the exact same time. Scale factors can be whole numbers like this too. Scale factors can also be 1.5. They can be 0.5 to cut them in half, make them half the size. Again, it does not matter what the number is. The process is the same. Multiply it by both the x and the y value of the point, and that will cause your shape to scale itself. And yeah, that is how you dilate a shape. Thank you for watching.